Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions. The mystery of Tabby's star update, new data, has only deepened the mystery of KIC 8,462,852. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 2015, citizen scientists working through the Planet Hunters project identified a star in the Kepler Space Telescope dataset that was doing something impossible. KIC 8,462,852, nicknamed Tabby's star after the astronomer Tabetha Boyajian, who published the first scientific paper about it, was dimming in ways that no natural stellar process had ever been observed to produce. Normal stars dim slightly and predictably when planets transit in front of them. KIC 8,462,852 dimmed by up to 22% over periods of days, with dipping patterns that were asymmetric, irregular, non-periodic, and utterly unlike anything in the Kepler database of 150,000 other stars. The dips were too large to be caused by a planet. Even Jupiter blocks only 1% of its star's light, too irregular to be periodic, and the light curves had shapes consistent with irregularly shaped solid objects of enormous size. When the story broke publicly in October 2015, the astronomer Jason Wright at Penn State University voiced what many were thinking. The light curves were consistent with what you would expect from a Dyson swarm, a mega-engineering structure built by an advanced civilization to harvest stellar energy. The media ran with this, and Tabby's star became the most discussed astronomical object of the decade. Subsequent investigations found another anomaly. Looking at historical astronomical records going back to 1890, the star appeared to have dimmed by approximately 14% over the preceding century, a rate of secular dimming with no known natural explanation. Two different types of anomaly, operating on two different timescales, both unprecedented in stellar astronomy. Then came the follow-up observations. Multiple research groups monitored KIC 8,462,852 intensively for years after the initial discovery. New dips occurred in 2017 and 2019. Researchers measured the wavelength dependence of the dimming during the dips and found that shorter wavelengths, blue light, were blocked more than longer wavelengths, red light, precisely the signature of dust, not solid objects. This pointed away from artificial structures and towards some kind of natural dust cloud. But the nature, origin, and stability of the dust cloud required to produce all of the observed anomalies remains deeply unclear. Several proposed natural explanations have been partially ruled out. No fully satisfying solution has been established. The star remains genuinely, stubbornly mysterious. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we go further, if you are finding this investigation compelling, please take a moment right now to like this video, drop a comment below with your thoughts, and share it with someone who loves a good historical mystery. If you are watching on YouTube, hit subscribe and tap the bell icon so you never miss a new episode. If you found us through Facebook, tap follow on our page. It takes just a few seconds, and it genuinely helps us keep making these documentaries. Now, let us get back to the investigation. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from T. Predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding Tabby's star update, new data, has only deepened the mystery of KIC 8,462,852 is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. KIC 8,462,852, located approximately 1,470 light-years from Earth in the constellation Cygnus, is an F-type main sequence star approximately 50% larger than the Sun and 7 times more luminous. It was identified as anomalous from Kepler data by citizen scientists participating in the Planet Hunters project operated by Yale University. The original Boyajian et al. Paper, published in the monthly notices of the Royal Astronomical Society in September 2015, documented more than 20 distinct dipping events in the Kepler data from 2009 to 2013, with depth ranging from 0.5% to 22%. The largest dip, designated D1500, dimmed the star by 22% over several days, corresponding to an occulting object with an effective cross-section larger than the star's diameter. This single data point, if taken in isolation, might be set aside. Anomalies happen. Instruments malfunction. Researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the secular dimming, the long-term, century-scale fading of the star, was first proposed by Bradley Schieffer in 2016 based on analysis of photographic plates from the Harvard Daisy digital access to a sky sanctuary at Harvard Archive, which contains photographic observations of the sky dating back to 1890. Schiffer found that KIC 8,462,852 had faded by approximately 0.164 magnitudes per century, corresponding to a roughly 14% dimming over 100 years. This secular dimming would be consistent with some slowly expanding or evolving structure around the star. A subsequent analysis by Hipk and colleagues disputed the secular dimming claim, finding it to be partially an artifact of the photographic plate calibration. The secular dimming question remains contested. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. The 2017 LC dimming campaign was the first real-time multi-wavelength monitoring of a Tabby's star dip. When the star began dimming in May 2017, the first predicted dip since the discovery, over 200 telescopes worldwide participated in monitoring the event. The crucial finding was wavelength-dependent dimming. The dip was deeper in ultraviolet and blue wavelengths and shallower in infrared. This achromatic vs. chromatic dimming distinction is critical. Solid opaque objects, like a planet or a Dyson swarm element, would block all wavelengths equally achromatic dimming, while fine dust particles scatter and absorb short wavelengths preferentially chromatic dimming. The 2017 observations confirmed chromatic dimming, strongly indicating that the occulting material is dust rather than solid objects. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the dust interpretation, while strongly supported by the 2017 wavelength data, creates its own set of problems. Dust in the interstellar system is rapidly blown away by radiation pressure or falls into the star. To maintain a persistent population of dust sufficient to explain the observed dipping over many years, there must be a continuous source of new dust, something that is being constantly replenished by some active process. Possible replenishment mechanisms include a disintegrating comet or asteroid, a planet recently destroyed by a stellar encounter, a collision between large bodies in the interstellar system, or some active volcanic process on a large body. Each of these has been modeled, and each can explain some, but not all of the observed characteristics. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of SETI researchers including Jason Wright and Andrew Simeon have advocated for radio monitoring of KIC 8,462,852 to test the extraterrestrial intelligence hypothesis. Multiple radio observing campaigns have been conducted, including monitoring by the Allen Telescope Array. No artificial radio signals have been detected from the direction of the star at any frequency. Optical SETI monitoring has also been negative. The absence of detected signals does not rule out alien activity. An advanced civilization might use communication methods we cannot detect, or might not be communicating at all, but it reduces the prior probability of the ETI hypothesis relative to natural explanations. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. A 2018 analysis by Mohammed Sheikh and colleagues proposed that the dipping patterns at KIC 8,462,852 might be explained by a family of orbiting dust clouds in a range of orbital periods, with the irregular dip pattern arising from the superposition of multiple partially overlapping clouds viewed at different orbital phases. This model can qualitatively reproduce the general character of the observed dips, but has difficulty matching the specific shapes of individual dips precisely. The model was judged by the astronomical community as promising but not fully convincing, and the search for a complete explanation continues. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Tabby's star update. New data has only deepened the mystery of KIC 8,462,852. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the disintegrating comet family theory proposes that the dips are caused by a large number of comets, possibly fragments of a larger body that has recently been disrupted, that are gradually disintegrating as they approach the star. The leading comet body produces a tail of dust and gas when heated by stellar radiation, and this dust cloud transits the star irregularly as different comets or comet fragments approach at different orbital phases. This model qualitatively explains the chromatic dimming, dust signature, the irregular timing comets approach on elliptical orbits, and the variable depth. Different comets produce different amounts of dust. It is currently the most widely accepted natural explanation among professional astronomers. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the post-collision debris theory holds that the dipping is caused by a debris disk created by a recent catastrophic collision between two or more large bodies in the KIC 8,462,852 system. The collision would have generated an enormous quantity of dust and fragments that are now spread in a broad arc or ring around the star, producing irregular dimming as different density regions of the ring transit the star. This model is consistent with the chromatic dimming observations, but requires the collision to have occurred in the astronomically recent past, within the last few thousand years, and predicts that the dipping should gradually become more regular as the debris disperses to a more uniform ring. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the Dysonian megastructure theory, ETI hypothesis, proposes that the dimming is caused by large artificial structures, a partially constructed Dyson sphere, a constellation of solar power satellites, or some other megastructure built by a technologically advanced civilization. before the 2017 wavelength observations. This was one of several active hypotheses. After the 2017 observations confirmed chromatic, dust-like, rather than achromatic, solid structure dimming, most astrophysicists moved away from this theory. However, a small number of researchers note that alien megastructures might be constructed from materials that produce dust-like dimming signatures, and that the ETI hypothesis cannot be completely excluded on the current evidence alone. What is striking about this debate is not merely that experts disagree. That is normal and healthy. In science, what is striking is the quality of the disagreement. Serious researchers working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Tabby's star update, new data, has only deepened the mystery of KIC 8,462,852 does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the 2017 multi-telescope campaign providing chromatic dimming measurements is the single most important piece of evidence constraining the Tabby's star mystery. The observation that blue light is blocked more than red light is a clear physical signature of fine particulate matter, dust, rather than large solid objects. This evidence significantly constrains the range of viable explanations and effectively ruled out the megastructure hypothesis in its straightforward form. The data from over 200 telescopes monitoring the same event simultaneously represents the most comprehensive real-time characterization of a stellar anomaly in history. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented. The Kepler Photometry Archive provides the baseline evidence for all Tabby's star research. More than 500 days of near-continuous high-precision photometry show the unprecedented diversity of the dipping patterns. Different depths, different durations, different shapes on the leading and trailing edges of dips. The statistical properties of these dips have been analyzed by multiple groups and consistently found to have no parallel in the Kepler database of hundreds of thousands of other stars. The uniqueness of KIC 8,462,852 in the largest photometric survey ever conducted is the foundational evidence that something genuinely unusual is occurring there. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed. Ground-based spectroscopic monitoring has detected variable amounts of gas absorption in the spectrum of KIC 8,462,852, with certain absorption lines changing depth over periods of weeks to months. These spectral variations are consistent with variable amounts of gas, possibly associated with the same events producing the photometric dips, passing in front of the star. The detection of gas alongside dust supports models involving active disintegration of solid bodies, comets or asteroid fragments, which produce both dust and outgassed volatiles when heated. Gas in the interstellar system dissipates even faster than dust, implying very recent and ongoing activity. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Tabby's star update. New data has only deepened the mystery of KIC 8,462,852. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. KIC 8,462,852 continues to be monitored by ground-based observatories worldwide under Boyajian's ongoing monitoring campaign. New dips were detected in 2018, 2019, and 2021, providing additional multi-wavelength data that is being analyzed for patterns that might distinguish between the competing natural explanations. The launch of the James Webb Space Telescope has opened up new possibilities for mid-infrared monitoring of the star that may help characterize the dust composition and distribution more precisely. JWST observations were proposed and approved in Cycle 1, with data expected in 2024-2025. Tabby's star has become one of the most important objects in the emerging field of anomalous stellar variability research, inspiring a broader survey effort to identify other stars with comparable unusual behavior. The Kepler dataset, the Transiting Exoplanet Survey Satellite (TESS) data, and forthcoming Rubin Observatory Legacy Survey of Space and Time (LSSD) data are all being searched for Tabby's star analogs. Several candidate objects have been identified, though none has yet shown the full suite of anomalous behaviors that KIC 8,462,852 displays. The star that started as a potential SETI target has become a Rosetta Stone for understanding the chaotic and poorly understood processes that occur in stellar systems undergoing active evolution, and its deepest mystery remains intact. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Tabby's star update. New data has only deepened the mystery of KIC 8,462,852, from the historical record through the physical evidence across the competing theories and into the modern significance of what remains unresolved. What the story of Tabby's star ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please help us reach more people. If you are watching on YouTube, subscribe to the channel and hit the notification bell so you never miss a new documentary. If you are watching on Facebook, tap the follow button on our page to stay connected. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment telling us which case you want us to investigate next. The conversation continues. The investigation never ends.